So, hello friends, good morning. Uh, in the last lecture, we have discussed the different types of force systems which are acting on the bodies. That is, first one is a concurrent force system, second is a parallel force system, and third one is it is called as a non-concurrent, or also we can call it as a general force systems. So these different types of system of forces which are acting on the bodies, that already we have discussed, and in the previous lecture already we have seen how to estimate the resultant of a concurrent force system. What we have done, we have calculated the summation of forces along x-axis, summation of forces along y-axis, and then we have calculated r, that is resultant, and theta angle made by the resultant with the x-axis. So this is what we have discussed in the last lecture. Now in this lecture we are going to discuss the resultant of non-concurrent force systems. This is also called as a general force system. Now before we go, we should know certain additional things to calculate the resultant of non-concurrent force system. The first one, you should know the concept of a moment of a force. That means you should able to take moment of a force about a particular point. Now you see, this is a point A, which is a hinge support, and this is a beam, and at this point this force is acting on the beam in the upward direction. So when the force will be acting upward, this A is a point of rotation. If I take this point A is called as a point of rotation, the turning effect produced by this force at this point, this is called as a moment. So now this force acting upwards, then how it will rotate the body, this particular beam, like this, which is this direction. This is called as a anti-clockwise direction, and the moment produced by the force will be m, will be equals to magnitude of force. Suppose force is 10 Newton, and the perpendicular distance, this is a line of action up to the point of rotation A. So this distance x is a perpendicular distance from the line of action up to the point A. So this f into x, this is a magnitude, and how it will act? It will act in anti-clockwise directions. So our sign convention, anti-clockwise movements, we are going to take it positive. Now the same force, this force, if it is acting in the downward direction, then it will produce the movement in clockwise direction. Magnitude will be same, f into x, because distance is same, everything is same. Only the direction is reversed, upward. Now it has become downwards. That's why the magnitude will same. So movement of a force on its line of action is equal to 0. This you must know. If this force is acting along this line, then it will pass through point A. When it will pass through point A, x will become 0. If you substitute x equals to 0, moment you will get 0. This is the meaning of this particular sentence. And one more thing you have to remember, the unit of a movement is Newton meter. If the force magnitude is given in Newton, then Newton meter. If distance is given in mm, then Newton mm. If the force is given in kilonewton, then this will become kilonewton meter. So I hope you understand. Again I will repeat, movement is what? It is a turning effect produced by the force on the body, and the turning effect only will be of two types. Either it will be anti-clockwise or it will be clockwise. Okay, and the unit is Newton meter, and magnitude will be magnitude of the force multiplied by the perpendicular distance x from the line of action of the force up to the point of rotation O. So I hope the concept of moment is clear to you. Now let us take a sample problem. Find the net moment of a given force about point O. First I will take this system of forces. You see, this is a line, horizontal line. This is a point, I will take this is a point of rotation. I want to take the moment about this point O. From this up to this line of action of this force, distance is 2 meter. From this to this, the distance is 2 meter. From this to this, the distance is 2 meter. This force is 10 Newton upwards, 20 Newton upwards and 10 Newton downwards. So net moment about point O, I will write it summation of MO equal to this 10. You see 10, the sense of rotation about point O will be like this, anti-clockwise. That's why 10 into perpendicular distance from the line of action up to O is 2. So 10 into 2. This is the moment of this particular force. And I have taken it positive. Next one, 20 Newton force. How it will give moment? Anti-clockwise about O. And that's why 20 into total distance. You see, from this line of action up to O, it will become 2 plus 2, 4. And anti-clockwise, that's why it is positive. Next is 10 Newton. What will be the sense of rotation about O? Like this, clockwise. So minus, clockwise means minus, into total distance from this line of action up to O, 2 plus 2 plus 2, 6. If you calculate, the moment will be minus 20 Newton meter. You see this total calculation, if you calculate, you will get minus 20. Minus, what is the meaning of minus? Movement is clockwise. 20 Newton meter, movement is clockwise of all these three forces about point O. Now second example, let us take, this is a point of rotation and this force is 10 Newton acting with inclination of 30 degree at point A. The total distance is 2 meter. Now first what you have to do, this is the point of application. You see, we have seen the characteristics of the force. This is point of application. So I will resolve this force into two components. Vertical component will be 10 sin 30 and horizontal component at this point A will be acting like this. See, components, direction of the component, vertical component will be upwards and horizontal will be to the left. So these components I have shown. So now if you take this moment of this force about O, you will find this 10 cos 30 according to principle of transmissibility. If you transfer, if you see the line of action, it will exactly pass through this point O, and that's why moment of this 10 cos 30, this component about O, it will become 0. Next is this 10 sin 30 about O, it will give moment in sense of rotation will be anti-clockwise like this, and that's why 10 sin 30 plus 10 sin 30 multiplied by distance is 2. So if you find out this total, you will get the moment is 10 Newton meter, it is positive, hence the net moment is acting in anti-clockwise directions. So these are the simple examples, parallel force system, which we have discussed. Next is the next very important concept, that is called as a couple. So the best example of a couple is when you open a tap of your wash basin, you will find one force you will apply forward and one backward. Similarly, you are paddling your cycle, how you are so these are the best examples of couple. So when two equal and unlike parallel forces are acting on a body, then it is said, it is called as a couple. You see, this force P upwards and this force P downwards, they are parallel but opposite in direction, and this is the lever arm, that is distance, perpendicular distance between these two forces. Now the moment of a couple, it is a product of magnitude of one of the force and perpendicular distance between. So this P and Q, they are same. Unless they are same, couple will not form. That is, remember, and that's why P and Q, they must be same. So the total moment produced by these forces, you just imagine, if you just take your fingers here, and just you see P is acting upwards, how it will rotate, clockwise. It will rotate clockwise. P and Q. How this will be rotate like this? This will rotate like this clockwise. And the movement produced by the couple will be force into perpendicular distance. You can take P or Q, they are same. P into A, this perpendicular distance. Don't make it P plus Q into A. It should be only one magnitude, because P and Q magnitude is same. So this is a couple, and the moment produced by the couple will be P into A, and unit also will be same, Newton meter. Now what are the properties of a couple? To form a couple, two equal and unlike parallel forces are must. That is what I told you already. Resultant of a couple is equal to 0. Resultant means if you take summation of y, horizontal direction there is no force. If you take summation of y, this P will cancel this Q because magnitude is same, and that's why resultant is always 0. Moment of a couple is equal to one of the forces and arm of the couple. That is what we have already discussed. Number of couples can be added algebraically. That means if anti-clockwise couple positive, and clockwise couple you take it negative. Suppose anti-clockwise 20 and clockwise 10. So 20 minus 10, the net couple will be, net moment existing there will be 10 Newton meter. So this way you should understand. Now the resultant of parallel forces. So let us see how to calculate the resultant of parallel forces. Resultant of parallel forces can be obtained using by adding all the forces algebraically. Let us consider the force system as shown in figure. So this is the same force system we are going to consider, this 10, 20 and 10. Okay. So is there any force in this force system acting in x direction? So summation of x is 0. So we know R is equals to under root of summation of x square plus y square. Summation of x square is 0 here. So summation of y will be 10. We know, we have seen upward forces positive and downward forces negative. Forces to the right positive and forces to the left they are negative. So this convention is applicable to this also. So 10 plus 20 because they are upward minus 10. So this is the resultant. This is the resultant, and we are getting positive means resultant is acting upwards. Here magnitude and direction of resultant is known, but the position where the resultant is acting on this line, where the resultant is acting, we know the resultant 20 Newton, but where it is acting. Therefore, in case of non-concurrent parallel forces acting with magnitude and direction, we have to determine its position with respect to some fixed point. Let us take this O is a fixed point. To determine the position of the resultant, we can use the Varignon's theorem of moments. So first we'll have to discuss what is a Varignon's theorem. So Varignon's theorem, what is, if this is the fixed point and this point we are calling it as a point of rotation where we are taking the moments. So at this point, if you take the moment of all forces, this force and this force, and we know we got that particular moment that already we have calculated in the previous example, moment of all forces about point O. So moment of all forces and moment of their resultant at point A, they are same. Moment, summation of moment of all forces equal to moment of their resultant about same point. This is called Varignon's theorem. So resultant we know 20 Newton upward. Okay, so to find out the position of resultant using Varignon's theorem, so this already we have done it. 10 into 2 plus 20 into 4 minus 10 into 6. This is the moment of all forces will be equal to, and what we have seen, the resultant is acting upwards. So this I have shown, but we don't know on this horizontal line where it is acting, and that's why from this fixed point of rotation I will assume the resultant lies at point A. So I will write down 20 into A. So the moment produced by the resultant about point O also will be anti-clockwise, and that's why I have written it positive 20 into A. If we solve this this complete expression, we will get the distance at which the resultant lies from point O, and it comes to 2 meter. Hence the resultant of this force system is 20 Newton upward, and it is acting at a distance of 2 meter from point O. So here I hope you clearly understand the uh, application of Varignon's theorem. Movement of all forces at a particular point will be equal to movement of their resultant about the same point. This is the Varignon's theorem. Okay. Now equivalent force system. You see this force system is equal to what we have seen. The resultant lies at a distance of 2 meter. Now this force, if I want to transfer at this particular point, then what you will do? To convert a given force system into a given force couple system at a point, apply a single force at that point and couple at the same point. The single force is the resultant of the system, and the couple is the algebraic sum of moments of all forces above the point. So to transfer this force from this to point O, what I will do? I will apply one upward and one downward force. So downward force and this upward, they will form couple. And what will be the magnitude of couple? 20 into 2, that is 40. Now it will be anti-clockwise. So this downward and upward, they will form couple, that I have replaced by couple, and whatever upward we have applied, it will remain at its place, 20 Newton. So in this way, I have transferred this force to this. This is called equivalent force couple system. So this system is equivalent to this. This system is equivalent to this. So I hope it is very clear to you. All these systems, effect produced by this or this or this on the body, it is same. I hope you understand in this lecture how to take a movement of a force. Also, you understand the practical application of the Varignon's theorem for locating the position of a resultant on the body with respect to the geometry of that particular body. I hope if these two concepts are clear with the help of this lecture, uh, I think our outcome is achieved. How to take a movement of a force. Second, clearly you should understand the Varignon's theorem. So in the next lecture, now I will discuss the resultant of non-concurrent force system, because in non-concurrent force system also we need this concept of couple as well as Varignon's theorem. So this part we'll discuss in the next lecture. Have a good day. Thank you. Thank you very much.